Question number 11. A box of mass 50 kg is placed on the horizontal floor. Bed of lorry, as shown in the figure. The coefficient of static friction between the box and floor bed is 0.8 and the lorry accelerates along the straight horizontal road. The maximum acceleration of the lorry can have so that the box will not slide over the floor bed is. When accelerating lorry, the box is trying to move in right hand direction because of lorry is accelerating in this direction. Therefore, the frictional force is the force against the motion of body, motion of this box. Now weight of box is 50 kilograms, it means 500 newtons. Reaction. Now we can get that frictional force, maximum frictional force. 500 into, we can use mu r, mu value is given as 0.8 into 500. Maximum frictional force is 400. Then we can find the acceleration corresponding to the maximum frictional force. We can use F equals ma for the box. F is 400, mass 50, we have to find acceleration. Then acceleration is 8 meters per square second. It is the maximum acceleration of the lorry. Then 3 is correct for the question number 11. Question number 12. Two identical wedges, each of mass mr, placed next to each other on the floor. A cube of mass capital M is placed on the wedges as shown in the figure. Assume that there is no friction between cube and wedges. The coefficient of static friction between the wedges and the floor is mu. The largest M that can be balanced without moving the wedges is given by. There are two wedges and there is a block like this. There are two forces on block due to wedges, same reaction, and we can mark weight of block mg. Then when considering vertical equilibrium of this box, there are two r cos theta values. We have to consider cos components because of this angle 45. R cos 45 plus R cos 45. Then 2R cos 45 is the vertically upward force. It should be equal to the mg. 2, we know that cos 45 is 1 over root 2 equals mg. Now we can simplify it. We can cancel out 2 and root 2. Then root 2r is mg. Now we can subject reaction mg divided by root 2. It is the reaction on this cube, and there is an equal and opposite reaction on the this wedge. Then we can consider forces on wedge, weight mg, simple mg. reaction capital R. The object, this wedge is trying to move in right hand direction because of there is a reaction component in right hand direction. We have to consider that friction is opposite to the direction of trying to move. Now I will consider vertical equilibrium of wedge. There is a reaction at this place, I will consider it as R dash. In considering vertical equilibrium of wedge, upward force R dash equals downward force mg plus cos component of this R cos 45. mg plus R value is this one, mg over root 2 multiplied by cos 45 1 over root 2. Then reaction is mg plus mg over 2, root 2 into root 2, 2. Now we can get that this frictional force is equal and opposite to the R sin 45 component. Frictional force equals R sin 45. Frictional force is R dash, mu R dash. Then we can get mu R dash equals R sin 45 1 over root 2. Mu R dash is this one, mg plus mg over 2 equals R value is mg over root 2 into 1 over root 2. Now we have to subject capital M term by using this equation. We can get mu mg plus mu capital Mg over 2 should be equal to mg over 2. Then mu mg equals mg over 2 minus mu mg over 2. We can cancel out g terms and we can multiply all terms by 2. 2 mu m equals m minus mu m. Then I will consider m as a common factor. 1 minus mu. 2 mu m. Then capital M value is 2 mu m divided by 1 minus mu. Then answer is C for the question number 12. Question number 13. A box is placed on a rough horizontal surface of a table is pulled by a variable horizontal force of magnitude F. For a given value of F, the resultant force R is exerted by the surface on box makes an angle theta with the horizontal direction as shown in the figure. The variation of theta with F is best represented by. We have to consider all forces on the box. Weight mg. Force on object is F. F is the pull. Reaction R and frictional force I will consider it as F dash. Mg and R are constant. Now we have to consider the resultant force R exerted by the surface on the box. It means we have to consider resultant of these two forces. It is marked as R, then I will consider reaction is R dash. Now we know that R dash is equal and opposite to mg. It is constant, it is not changing. But increasing this f value, this f is increasing and becomes a constant. Therefore, the resultant force should be near to f dash force and it should constant. Then theta value should be decreasing and finally becomes a constant. You know that frictional force is varying like this. Then angle theta should be decreased and becomes a constant. Then answer should be 1 for the question number 13. Then 14. A block of mass M kept on the horizontal truck bed is at rest with respect to the truck when it is moving horizontally with a constant acceleration A. The coefficient of static friction between truck bed and mass is mu. The frictional force acting on the mass is given by. I will consider object on the truck bed. If the truck bed is accelerating A, this object is trying to move in opposite direction. They have given that it is at rest with respect to the truck. Therefore, frictional force should be equals to, we can use F equals ma for the object. Frictional force should be equals to mass into acceleration of the box. Then you can substitute frictional force is mu r. It is equal to ma. Reaction is equal and opposite to the weight. Then we can substitute reaction mg. We can cancel out m. We can get directly the frictional force acting on the object should be ma. Then answer is 1 for the question number 14. 15. Consider two motor vehicles A and B. In motor vehicle A, only of the front wheels are coupled to the engine and rotated. And in vehicle B, only rear wheels are coupled to the engine and rotated. Which of the following diagrams correctly shows the direction of frictional force acting on the front and rear wheels of motor vehicles A and B by the gum when they are traveling in forward direction. In vehicle A, only front wheels are coupled to the engine. Therefore, when considering vehicle A, frictional force on front wheel should be in forward direction and rear wheel should opposite to the movement. In vehicle B, rear wheels are coupled to the engine. Then on rear wheels, frictional force is towards the motion, and on front wheel, frictional force opposite to the movement. Then we can get fourth one is the correct answer for question number 15. Now question number 16. A rectangular block rests on an inclined plane as shown in figure A. The direction of the resultant force exerted on the inclined plane by the block is best represented by the resultant force exerted on inclined plane by the block. Block should be like this. Then we know that when marking forces on block, mg and reaction. This reaction is the force given by the inclined plane. Therefore, force on the inclined plane by the object should be equal and opposite to the reaction. The reaction equal and opposite to the reaction. And there is another force. If it is at rest, there should be a frictional force. Then there is an equal and opposite frictional force to the inclined plane. Then the force exerted on the inclined plane is resultant of these two forces. We know that frictional force equals to mg sin theta. It means a component of mg. And we know that R is greater than this frictional force because of R is due to the weight of the object. Then this resultant should be near to R. Then we can get fourth one as the correct answer for question number 16. 17. A small object of M placed on the horizontal surface of a frozen point is given a kick imparting an initial speed v0 along the horizontal direction. The object moves on the surface in a horizontal straight line without rotation. The coefficient of kinetic friction between object and surface is mu. If the air resistance can be neglected, the distance of the object move before coming to rest. We have to consider that the work done against the frictional force. It means frictional force into distance should be equal to initial kinetic energy of the object, half m v square, v naught square, according to the conservation of energy. This is the initial energy, this is the energy lost. Finally, the object has no kinetic energy, therefore total kinetic energy of the object should lose due to friction. We can substitute frictional force mu r x equals to half mv naught square. We can substitute r reaction. We know that when the object is facing in horizontal surface, reaction equals mg. Then mu reaction mg x equals half mv naught square. We can cancel out m and m. Then we can subject x v naught square divided by 2 mu g. Then answer is 1 for the question number 17.